Graphics technology for video games improves every year. Let's take a look at one of the possible key future technologies known as ray tracing. What does ray tracing even mean? And how does it work in terms of graphics? Ray tracing is a form of lighting and CGI in graphics programs that's moving to video games in the distant future. In real life, we have photons of light, which are atomic particles emitted from sources of light that reflect, refract, and get absorbed into objects. Ray tracing works very similarly. A source of light bounces tiny particles around a level in order to accurately simulate light like in real life. This type of simulation is highly accurate and is ultimately the only way to make realistic lighting in games. But it isn't without its fair share of problems. Before we go into these issues, however, I want to clarify what I'm talking about. I'm always skeptical about demos that have several stupid mirror-like objects in a shiny room where everything is ridiculously sparkly and reflective. You can forget about this completely. I'm talking about this kind of ray tracing. You'll notice the sandy effect that it's making, and I'll talk about that later. But for now, just remember that when I'm referencing ray tracing, I don't talk about those stupid, unrealistic demos, but I'm instead referencing the kind of light bounces used in rendering. This type of technology isn't quite here yet, and we'll only see it likely in the distant future after all the next-gen computers and graphics cards are out. Now let's get into some issues. First of all, it is slow and time-consuming to render several tiny particles every single frame. Today's hardware simply isn't up to the task of performing such a feat. In most real-time demos and programs today, the scene produces a grainy effect because the particles of light are far too slow for an acceptable frame rate. This is why ray tracing is often used in programs like Blender, 3D renders, or CGI simply because performing convincing ray tracing in real time is not really possible right now. The second thing is that ray tracing, in its current form for games, is not really practical or even needed at all. We already have stuff like approximate lighting and real-time effects that fairly accurately simulate light like in real life. This kind of technology isn't perfect either, but it's optimized well enough so that we can actually run games on it. At some point, however, graphic standards will rise and we'll need a new type of lighting in games. But this problem will be easily fixed without ray tracing and with shortcuts. Instead of making higher resolution monitors to display the better quality game images, we've invented anti-aliasing to get rid of visible jagged lines. The same goes for details in models, specifically with polygons. Instead of pumping iron and increasing the amount of polygons dramatically to render a tree, for example, we've invented tessellation to simulate smoothing out on any edges or restrictions that polygons give us. With graphics, we have a history of really not fixing the problem, but instead shortcutting around it to find a good way of cheating the system rather than actually using the real thing. And the same will happen to lighting in video games, where ray tracing will cease to be a viable option when newer and more efficient models come around in the future. Of course, it does have its benefits. If the goal of a game developer is to create a truly photorealistic game, then ray tracing is really the only way of doing it. Like I said in the intro, it's the best way of simulating light like in real life. Our eyes are incredibly finely tuned and can tell the difference between an image and an actual photograph taken of an actual place. Ray tracing is very good at simulating lighting already, and the only limiting factor is the hardware. So in conclusion, I don't think game developers should invest in the technology right now. Our computer improvements are slowing down as graphic standards rise, and ray tracing is too much of a bar to reach in terms of creating realistic lighting. I mentioned that in the future we'll most definitely find a way of simulating accurate lighting in another way, hopefully making this technology possible, but in a much more efficient way. I say stick to ray tracing to photorealistic images in CGI and leave it at that. Ray tracing unfortunately won't come to video games for a long time. That technology is pretty cool though.